Now we're going to start solving equations that have radicals in them. So a radical equation is an equation in which the variable appears in a radicand. The principle of powers states that if a equals b, then a to the n equals b to the n for any exponent n. So let's look at some samples. Whenever you're working with radicals, you want to get rid of the radical sign in order to solve the equation. You want to isolate the radical first. So if there's anything else on the same side as the radical, then you want to move it. Once the radical is isolated, like it is in the first example, then what we're going to do is get rid of the radical sign. So in this case, we have a square root. So what is the opposite of a square root? Well, that would be to square. Squaring a square root, those are opposite operations, just like multiplying and dividing are opposites and adding and subtracting are opposites. So the result is 3x minus 7, no longer underneath the radical sign because we squared it, and the square root canceled, and then 5 squared equals 25. Now we have an equation that we can solve for x. So add 7 to both sides. I end up with 32, divide by 3, and x is going to equal 32 thirds. Now on this next one, I'm going to have to isolate the radical first, so I need to add 3 to both sides. Once I do this, then I will be able to get rid of the radical sign. So that's going to be square root of 6x equals 10. Now I can square both sides. And that's going to give me a new equation of 6x equals 100. Divide by 6, and x is going to be 100 over 6, which reduces to 50 over 3. The next one, we have a similar situation. We need to isolate the radical first. So that's going to give me square root of n minus 8 equals 3. Now I can square both sides. And that's going to give me n minus 8 equals 9. I'm going to add 8, and that gives me n equals 17. Now what happens if you have a square root on both sides? Well, the same idea. How do we get rid of a square root? Well, we're going to square both sides. That's going to leave me with 6z plus 1 equals 5z plus 3. Now I need to collect all of my z's on the same side. So that's going to leave me z plus 1 equals 3. Move my 1, and z equals 2. And just like when you're solving any other equation, you can always check your work by plugging in your answer back into the original, and it should work out. So this would be a very easy mental check. The other problems that had fractions in them, you'll probably want to use your calculator to help you check, but either way, you can check your work.